Hi there, my name is Tim Warner. Welcome to my course, Backing Up Virtual Machines in Microsoft Azure. I'm a Pluralsight staff author, Microsoft MVP, and Azure Solution Architect. This beginner-level course is aimed at IT operations professionals who are responsible for providing disaster recovery for Windows Server and/or Linux virtual machines running in Azure. By the end of the course, you'll know how to back up and restore VMs in Azure. You'll understand how to restore virtual hard disks, as well as individual file and folder resources from VM restore points. I hope you'll join me on this journey to master Azure VM disaster recovery and our Backing Up Virtual Machines in Microsoft Azure course at Pluralsight. Hello and welcome to Pluralsight. My name is Tim Warner. I'm happy to be your instructor. This course is entitled Backing Up VMs in Microsoft Azure. This is the first module of the course, and it's titled, appropriately enough, Backing Up VMs. What we're doing in this course is looking at disaster recovery for your Microsoft Azure virtual machines. We're going to start with the basics and then get gradually more complex as your skills increase. We're going to start with VM disk snapshots, both in the unmanaged and managed disk scenarios. You'll then learn how to perform manual and scheduled backups of your Windows Server and Linux virtual machines running in Azure. And you'll understand that configuration from two perspectives: the VM, which is my favorite way to go, or the more centrally located Recovery Services Vault. Let's get started. To find the exercise files for this course, in the Pluralsight web player, navigate to the Exercise Files tab and click Download Exercise Files. Every Pluralsight course includes a zip file that includes two main things. One, PDF representations of all of my slide decks, and also links lists. There are text files that I fill with links and references that I refer to in the training and that I think may be helpful as you work in your Azure skill development. Where relevant, I'll also share my PowerShell source code with you in those files as well. VM disk snapshots. Now let me say right off the bat that when you're backing up your VMs in Azure, in general, I suggest backing up the entire VM, which is not only the OS and data disks, but also the configuration itself. That having been said, there are plenty of good use cases for backing up the disks themselves minus the VM configuration. Recall that in Azure, your OS and data disks are Hyper-V Generation 1 VHD files that are stored as page blobs in Azure storage accounts. You can snapshot these, particularly in the managed disk scenario, to create full and incremental point-in-time snapshots of the disk state as of that time. Some administrators like disk snapshots because, frankly, it's faster than performing a full backup. Because your subsequent snapshots are deltas or incrementals, you're going to find that those complete very quickly. As I said, you can do snapshots for both managed disks as well as unmanaged. In my Azure consulting practice, I always guide my customers to use managed disks for so many reasons. Ease of administration is certainly one of many, but you can do this even with unmanaged disks, which are your VHD files stored in Azure storage accounts that you manage as opposed to Microsoft managing them. With unmanaged disks, of course, you get a less seamless experience. You'll need to use a tool like the AZCopy command line tool to archive your snapshots to another storage account, for instance. Now, snapshots cannot outlive their source blob. What that means is if you delete a VM and its original OS and data disks go up the flue, then any snapshots are going to be irrelevant. They're tied to the source blob. Keep that in mind. And you can, in fact, create new VMs from a snapshot. I'll show you how to do that, actually. How do we restore a managed disk from a snapshot? Well, in Azure PowerShell, we can, in this code, use get Azure RM VM to get a reference to a virtual machine object. We can do the same thing with get Azure RM disk to retrieve references to the disks from a particular backup. We then set Azure RM OS disk using the managed disk ID and the disk name, and then update the virtual machine with the disk. Now, what this code just does is restore a disk from a snapshot. So that means a virtual machine could have an OS or data disk that's become corrupted or suffered file loss or, heaven forbid, a crypto locker attack. And you can retrieve a managed disk snapshot and apply it back to the virtual machine. If you've used PowerShell before, this is really bread and butter PowerShell that you see on this slide. No big surprises. With unmanaged disks, to restore one of those back to a VM, it's a little more work because, as I said, in the unmanaged disk scenario, you're responsible for the full life cycle of the VHD. What you'll want to do is in your backup storage account, you'll want to promote the backup snapshot that you want to use to make it a restored standard disk. After that promotion, you're going to snapshot that disk to create a restored blob backup that you then copy over into your storage account that you're using for primary storage for the virtual machine. Now, it says premium and standard. Those are just guidance. In this example, we're using premium storage in our production and standard in the backup. That's fine, but it doesn't have to be that way. They could both be premium, they could both be standard. You restore that blob snapshot and then apply it to the VM. So it's just basically you have to do some additional plumbing work in your storage accounts with unmanaged disks. If you've used managed disks before, then you know everything is abstracted for you. All of the back-end plumbing is already abstracted for you, so you have a much more direct path. In this demonstration, we'll work with managed disk snapshots in Azure. Taking individual disk snapshots can be useful in various use cases. However, keep in mind the easiest way to back up and restore entire VMs is to perform a VM-level backup. That said, let's, in the Azure portal, open the Virtual Machines blade, and we're going to pick on a VM called Web1, so I'll just filter the list for that name, and I'll select it. We'll filter the settings down to disks, and we see that we have an OS disk but no data disks. To take a snapshot of that OS disk, we can simply select it, and then in the resulting configuration blade, click Create Snapshot. I'll give the snapshot a name. I'll store it in its existing resource group called LB. I'll ensure the account type is standard HDD, and we'll create that snapshot. Okay, the snapshot creation process took just a minute. As you can see in the notifications, the snapshot was created successfully, so that's fine. Notice the export button while we're here. As long as actually let me click it and show you. As long as the virtual machine is in a stopped and deallocated state, or if the disk is unattached from the VM, you can export it, which means downloading a copy of that disk. Let's take a look at snapshots now. Those are tracked in a separate resource blade or a service blade. Let's filter the list for Web1, and there's the snapshot that we just created. Let's give it a click. Remember what I said in the theoretical part of this module, that the snapshots are tethered to their source disk. Here's that export option that I was talking about. The way that the export works is that Azure creates what's called a shared access signature, or SAS URL. And this is a time-limited URL. You'll want to set the expiration appropriately for your use case. Here we have a direct download link, and here's the full URL if we need to do so. SAS tokens are useful to get access to blob assets, but you want to be careful to protect the URL because anybody can use it as long as the URL falls within its lifetime. Now, as far as creating a new VM from a snapshot, let's take care of that use case in Azure PowerShell. We'll switch over on my Windows 10 management computer to Visual Studio Code. I have a script file called Create VM from Snapshot. You'll find this file in your exercise files. Up at the very top, I have a multi-line comment that gives you a link to the Microsoft Azure documentation article where I've adapted their code. Thanks very much, Microsoft Docs team. We're going to start by defining some variables to store my Azure subscription ID, the resource group, and the snapshot name. I put a hyphen in that. Let me actually select these lines. Let me back off the zoom just a little bit, lower my integrated terminal, and I'm doing Shift-click, and then I'll run just those lines. Next, we track the name of the OS disk that'll be created using the snapshot. Next, we'll create a variable for the target virtual network. I'm going to place the new VM in a separate virtual network. I'll provide the name of the virtual machine, and then we can choose a different size. So this represents a use case, as I already said in the theory portion of this module, to where you can take a disk snapshot and give it a completely different new virtual machine configuration. This line here is, or this selection here is important. Get Azure RMVM size. Remember that instance sizes are location dependent. So in my home region here, East US 2, it gives us a big old list of instance sizes that are available. And you can see that the default output gives you the bare minimum, but useful information, number of virtual CPU cores, memory, maximum data disks, etc. I'm going to use the standard D3 V2 size. Next, we'll want to set our subscription context just to be absolutely sure that we're linked to the right subscription. And now we start to get into the higher weeds. We're going to create a variable called snapshot that retrieves the snapshot that I just created. Next, we'll create a disk configuration using that snapshot. Essentially, what we're doing is creating a new managed disk based on the snapshot. That's what line 37 does. So we retrieve the snapshot and we create a new disk of it. Now, in my case, I had to make a change in my line 37 here to specify a new existing resource group name. When I used the LB resource group name, I got an error saying changing property creation data is not allowed. That makes sense because the disk in question, remember, we created a snapshot off of the Web1 OS disk. All of that is contained in the same resource group, so we wound up having an object conflict. So I'm going to place the new disk in a separate resource group that I created. In fact, here's the code right here. It's very easy in Azure PowerShell. Finishing it out now, we can create the virtual machine configuration here on line 40, and then we'll set that new managed disk we created into the virtual machine object. You can specify the operating system here, Windows or Linux. Then finishing it out, we'll create a public IP, and we'll get a reference to our target virtual network. We then, through lines 46 through the rest of the script, just work through creating a new public IP address, getting a reference to the target virtual network, creating a network interface, and binding it to the virtual machine configuration. As a sanity check, let's come back to the portal, back to the virtual machines blade, do a name filter for Web1, and then on the final line here, line 56, we finally create the actual virtual machine, passing in the virtual machine configuration, the resource group, and the location. As a sanity check, we'll finish off by coming over to the portal. If we do a filter for web again, you can see we now have two Web1s, one in the LB resource group and the other one in my new resource group called Restore. And it has a public IP address, and it's on the hybrid VNet virtual network. We need to keep in mind issues of these machines have an identical operating system disk now. So keep that in mind as we're going along here. But I think I've sufficiently trained you how to create a new VM based on a OS disk snapshot. Now let's turn our attention to backing up VMs in Azure. Now the Azure VM backup landscape consists of a number of different options. We started with the very basic VM snapshots, and you know how to apply those back to a VM in the case of recovery. I also told you that I strongly suggest that you perform honest-to-goodness VM backups. You probably do that every day or every night, technically, on premises, so that you can capture not only the virtual hard disks, but also the VM's configuration. At base, we've got the Microsoft Azure IaaS VM Backup. This is a VM extension that you add to the VM, and you can back up either on schedule or on demand to a recovery services vault. And then, as my friend Oren Thomas says, Bob's your uncle. If you're integrating in a hybrid cloud and you have on-premises physical or virtual machines, you can install what's called the Microsoft Azure Backup Agent, or MARS, Microsoft Azure Recovery Services Agent. That's what MARS stands for. And this agent will allow your on-premises servers to back up, unfortunately not whole disk backup, only file and folder backup, to the recovery services vault in the cloud. If you do have need to do system image backups or full VM backups on-prem into Azure, you can use something like System Center Data Protection Manager. or there's an Azure-specific version of System Center DPM called Azure Backup Server, or MABS. MABS stands for Microsoft Azure Backup Server. Now, those are a lot of options, aren't they? We're going to stick to the Azure IaaS VM backup in this scenario in this course. Some general notes for Azure VM Backup. Think you're going to find that the experience here is super easy. The product groups at Microsoft have done a great job of integrating this and making it seamless even into the VM creation process. You're going to need what's called a Recovery Services Vault to do any Azure VM backup. This means you don't have to worry about storage accounts at all. All of the storage is abstracted and Microsoft takes care of that. The Azure Backup Service uses, as I said, an extension, VM Snapshot extension for Windows Server virtual machines and VM Snapshot Linux extension for Linux virtual machines. With Windows, you know you have the Volume Shadow Copy Service, or VSS, that orchestrates consistent point-in-time snapshots of OS and data disks, preferably while the server is running. In fact, it's actually recommended that you do your backups while the server is running. I mean, I'm sure they are anyway. You get a better consistency when VSS is brought to the table. Speaking of consistency, it's important that you understand the consistency levels. There's 3 of them that are supported in Azure. The first backup consistency level, the best one, is application consistent. This is the preferred backup type in which your data is consistent with the time of backup thanks to VSS. So Azure is confident with their service level agreements that in a restore situation, the VM will boot up, your applications will work, and your files will be current as of that backup. That's the best kind of consistency. File system consistent will ensure that the VM boots and there's neither corruption nor data loss, but it doesn't guarantee a point-in-time recoverability, and you may need to perform some fix-up actions to bring data current in the VM. Least preferable is the crash consistent consistency level, and this is least preferred. It's what happens if you back up a powered down VM, and it's the rough equivalent of when a server experiences a hard freeze and you have to bring it down and do a hard reboot to bring it back online. You might find after doing a restore of a crash consistent backup that Windows will have to run check disk operations to ensure disk consistency before the operating system loads. The good news is that Azure VM Backup will record the type of consistency that it applied for each of your backup snapshots. In this demo, we'll look at doing honest-to-goodness VM backups in the Azure portal. We're looking right now at the Recovery Services Vault displayed because, as you know by now, the VM backup and restore operations, as well as Azure Site Recovery for that matter, all happen within the context of the Recovery Services Vault. You can see I have a few created, and if we pop into one for a moment, one of the things you'll notice is there's no reference to a storage account. This again speaks to the fact that the Recovery Services Vault is all managed storage. You're not concerned about that. That's an essentially limitless pool that Microsoft takes care of. If you come down to getting started, you'll see that there's 2 getting started paths. We're concerned with backup right now. And actually what this getting started is, it's essentially an interview process that asks you where your workload is, whether it's Azure or on premises, and then depending upon what you want to back up, it'll walk you through the process from there. What we're going to do is use the integrated backup functionality that we can get to from the VM's perspective. So let's do a search for web here. And I want to pick on my Web 2 virtual machine. This is a Windows Server 2016 web server, but it just as well could be Linux here. It doesn't matter at all what the guest operating system is. And if we come in here and scroll down the list, under Operations, we have Backup. Let's go there. And the first thing we're asked to do is to either create a new Recovery Services Vault or select an existing one. Now, keep in mind, Recovery Services Vaults need to be in the same region as your virtual machines. Okay, that's really important to know. I'm using EastUS 2 for most everything, and that's where my hybrid vault Recovery Services Vault is, so that's fine. Now, the backup policy is where you can do retention, and there's various levels of retention. We'll take a look at those options in just a moment. But right now, I want you to see how easy it is to do a backup here. You just enable backup, and off you go. You might remember also that in the portal, during the virtual machine creation workflow, one of the options is a simple, do you want to back up? Yes or no? Long story short, the Azure development teams have made it super easy to enable backup for your virtual machines. Okay, after we've enabled backup for the virtual machine, the backup settings panel shows this, which is essentially a dashboard. And what I want you to see is under backup status, the pre-check is passed, but we actually haven't initiated a backup yet, okay? So to do that backup, we can click backup now. We're asked when we want to retain the backup until, and then click OK, and we're off and running. Each backup is referred to as a restore point, and you can see that the key performance indicator down at the bottom will give you a running total based on consistency level. Now, we initiated this first backup manually, but I'm sure you're thinking, at least I hope you're thinking, well, Tim, how do we schedule this to happen? All of that happens in the context of the backup policy. And if I scroll to the right a little bit, we get a hyperlink to that backup policy. We give it a click. In the VM perspective, it just allows us to change an existing policy, but we'll need to go into the context of the Recovery Services Vault to create a new one. Notice that the backup frequency is daily here. And then again, the retention range of your backup points is going to depend upon your other parameters. Okay, let's take a look at the Recovery Services Vault, and we can take a look at the Hybrid Vault resource. The overview page gives us a dashboard. Notice that we can flip back and forth between site recovery and backup perspectives. Gives you a list of any alerts in the past 24 hours, your storage footprint, and your backup items. Actually, let's go to backup items. Notice that in the Recovery Services Vault, we can back up a lot more than Azure virtual machines. There's a whole bunch of options for on-premises virtual and physical servers. Check my Pluralsight course on migrating physical servers to Azure to learn how that works. Let's go to Azure Virtual Machine. Here's our hybrid VM. Its last backup was a success. Let's select the server in the list, and it looks like we have 2 application-consistent recovery points. This is a good thing. Actually, we're looking at a different VM, aren't we? I selected hybrid VM instead of Web 2, which was the one that we were working with. Uh-oh. Well, anyway, at least you can see what it looks like once a backup is complete, and you see that the other options for restoration, particularly restore VM and file recovery, are now lit up. Let's come back one step in the breadcrumb navigation trail, and we can see here that my Web 2 backup job should be running. Let's give it a click. Still showing initial backup pending. Let's come back to our Recovery Services Vault, the root of our hybrid vault, and if we filter the list for job, we can look at our backup job list. Aha, this is what I wanted to see. The backup's going to take a little while because it's an initial backup. Subsequent backups, I hope it makes sense to you, are going to be incremental jobs and should take less time. Here we can select the job details, and it shows us exactly what's happening here. All right, to finish out this demo, let's again step back into the Recovery Services Vault setting, and let's look at policy, because I've mentioned that a few times. And under policies, we have backup policies, and that we've got default and daily, and we can also create a new one. Let's just show you what this looks like. We have policies in the Recovery Services Vault that cover 3 main use cases: the virtual machine, the Azure Storage Account file share, and when you're running SQL Server workloads in IaaS. We're going to select Azure Virtual Machine. And besides giving the policy a friendly name, we specify the backup frequency. And this works either daily or weekly. And then we have our retention range. You've got daily, weekly, monthly, and yearly backup points. You're probably familiar with the grandfather, father, son way to archive backups. The idea here is you can create a policy that matches both your disaster recovery and recovery time objective, recovery point objective needs, and help you pass your compliance audits if you need to document that you have your disaster recovery set up in just such the right way. In summary, what have we learned in this first module? Well, I think you'd agree with me that Azure makes VM backup very seamless. The fact that you can enable backup during VM creation is a wonderful convenience, and the VM backup tools that are integrated directly in the VM blade in the portal means that you have backup right under your nose, so to speak, and it's a lot more difficult to neglect this important task when you have the option staring you in the proverbial face. We started this lesson doing disk snapshots, and the takeaways from there are to make sure that you're using managed disks in all cases. You can actually migrate unmanaged disks into managed format using Azure PowerShell. Check the exercise files for a help link on that, and understand disk snapshots as a special purpose backup type. They're very fast. They don't include the VM's configuration, but they do in fact give you a point-in-time recoverability of those disks. And maybe you might want to use one in a generalized state to create a golden image for future VM deployment. I actually created an entire course for our Pluralsight Microsoft Azure partnership. Check it out if you're so interested. In the meantime, now that we have good backups, we're going to restore those backups in the next module. I'll see you then. Thanks very much for your participation. Hello there and welcome to Pluralsight. My name is Tim Warner. The name of this module is Restoring VMs. If you're coming to this module from the previous one, then you understand the workflow for backing up your Windows Server and Linux VMs in Azure using the VM Backup extension and the Recovery Services Vault. Today we're going to start by restoring entire virtual machines in Azure. We'll also look at restoring individual disks, and we'll finish by verifying recovery by testing access to those restored virtual machines and disks. Let's begin. Restore virtual machines in Azure. The Azure VM Backup and Recovery features in the Recovery Services Vault give us three options. Number one, we can restore an entire virtual machine. This is going to bring back the OS and any data disks that are part of that recovery snapshot, as well as any configuration. You can restore to the original location, assuming that you've deleted the source or failed VM, or to an alternate location. You may have to recreate or reattach other dependencies, as we talked about in the previous module. Second, there's the scenario of restoring individual disks. Now, before Azure File Recovery came to be, that's going to be the third recovery option to let the proverbial cat out of the bag. If you wanted to pluck file system resources from a backed up data disk, you would need to restore the individual disk and then either attach it to a VM or download it or do something like that. But basically, you're restoring the individual disk or disks to a storage account, and the Azure VM Backup and Recovery toolset will helpfully include an ARM, Azure Resource Manager JSON deployment template, to help you work with the disk if you want to reattach it. We use the individual disk option for other use cases. For instance, here's a really good one that I've seen in my work as an Azure Solutions Architect. When you restore an entire VM, you're assuming the configuration of the VM as it was backed up. However, if you have OS and or data disks that you want to attach to a new VM that has a different configuration, see what I mean? This is a good workflow example for when you would use the Recover Individual Disks option. In short, use this option to fully control the VM restore process. Third, as I mentioned, we now have the ability to restore individual files and folders from your backed up VM, OS, and or data disks. The way this works, we're actually going to cover it in a separate module, is that you will mount the backed up OS and data disks as network drives on your local workstation. It's a very inventive way to go, and it's orchestrated through PowerShell. So we click delete and open the notification bell to follow the execution of that delete command. Again, we're simulating a catastrophic failure or perhaps an inadvertent virtual machine deletion. This stuff happens, but we know we'll be able to restore the virtual machine because we have at least one good backup. Now, I want you to understand that executing this delete operation, as you can see, it's gone from the virtual machines list, but the dependent resources still exist. For instance, we can go to disks, and we'll open the disk service, and we'll filter by name, and here's those hybrid disks right here. But we can still simulate a catastrophe by selecting a disk and choosing to delete it, which we'll confirm right here. We'll wait for this to complete. Actually, what I want to do, I should have selected that data disk too. I really want to go all the way with this example. So let me again do a search for hybrid, and I'll select the data disk this time, and we'll delete it. So at this point, the virtual machine configuration is gone. the OS and data disks are being deleted, as you can see in the notifications area. And we're in a world of hurt, aren't we? Well, not so fast. Let's go to the appropriate recovery services vault. I have a few of them. We might need to search around a little. No, this is it, because this is the only one in the proper version. Remember that recovery services vaults need to be in the same region as the virtual machines that they protect. Let's select Hybrid Vault, scroll down to Protected Items, and we'll select Backup Items. This is an Azure virtual machine, of course, so we'll select it. And then we'll select Hybrid VM. What we want to do, of course, is a restore operation, so we'll click Restore VM. We want to choose the appropriate restore point. I'm in a good position here because I can choose between two application-consistent restore points. Of course, I'll select the most recent one. And this is important here. First of all, notice the information message that says that if we want to create an alternate configuration when restoring your VM, in other words, if you want to choose different metadata, different instance size, different configuration, you'll want to use Azure PowerShell for that. Check the exercise files for this course, and I'll give you a docs link. But here, assuming that we want to put the virtual machine back in its original location, we'll make sure to choose Create Virtual Machine under Restore Type. Virtual machine name is Hybrid VM. The resource group, we'll try to put it back in its original Hybrid RG resource group. Open up the virtual network, we'll put it on its original virtual network, its original subnet, and we need to choose a storage account for staging. And I'm going to choose my EastRG Diagnostics account. That's fine. Click OK. And now we can flip the switch. We'll hit Restore. And in the notifications bell, we can wait for a link to show up, and then we can track the job status. Here we go. There's the link. We'll select it. It'll take us into the backup job setting in the Recovery Services Vault, and we can follow this restore process. Let me select the item, and we'll look specifically down at the bottom as the subtasks list populates. Notice that the two tasks are to transfer the backup data from the vault, and then, of course, to create the restored virtual machine. Okay, our restore operation for the VM has completed. You see I've got a couple other jobs that have come in afterwards, but we can select this row here and verify that both the data transfer and the restored virtual machine operations have finished. The name of the target VM is Hybrid VM, so we should be able to search for it here in the search list. Here it is. It has its public IP address. It's on a virtual network, and if we come over to disks, we have our OS and data disks back exactly where they should be. Good deal. We're back in business. Restore individual disks. The way that you can, for instance, create a VM using restored disks and fully control the process, as I mentioned earlier, happens like this. The first step is restoring the appropriate VHDs to a storage account. Next, you'll create a VM configuration. In all likelihood, you're using Azure PowerShell or the Azure Command Line Interface, CLI v2. Finally, you attach the OS and data disks to that VM configuration and deploy away. As I mentioned a few minutes ago, Azure Resource Manager templates are a really good use case for this scenario. In this demonstration, I'll teach you how to restore individual VHDs from backup. Here in the Recovery Services Vault, let's scroll down to Protected Items, Backup Items, and we want to pluck a VHD from an Azure virtual machine. We choose the virtual machine in question. I'll choose Hybrid RG. Note that this could be a VM that's long since been deleted. We're working on backups that exist in the Recovery Services Vault, so I hope that you understand that in order to be able to pluck a VHD, we're going to have to either have a snapshot or an honest-to-goodness backup. And here we can do a restore VM operation on this VM. We'll select the appropriate restore point. Actually, let me go back in time a few hours and choose this first application consistent restore point. Click OK. For restore configuration, instead of create virtual machine, we'll select restore disks, and we'll restore those disks into a resource group I have called, appropriately enough, restore. We have to select a staging location, a storage account staging location. I'll choose EastRG Diag, and click OK. Now, if you see any errors, they'll show up immediately. We do have a validation error here. Let's see. Okay, so the error code is that I have a restore operation currently in progress for the virtual machine. And the recommended action is to simply wait. Well, this is an easy to fix error. We could either wait or we can come back to our backup items blade and choose to restore a VHD from another virtual machine. I do happen to have one called Web2. We have one application consistent backup. That's good enough to retrieve one of its VHDs. In fact, I think on this VM, there's just the OS disk. Let's go to Restore VM again. This is good practice, isn't it? We'll select the restore point, proceed. Once again, we'll select Restore Disks. We'll choose the appropriate resource group. We'll choose the appropriate staging location and click OK. Validation passed, so we now can initiate the restore operation. And once again, we can watch the progress through the jobs. Now, I've had us go up here into notifications, but I also want you to know, let's go back to our Recovery Services Vault. We do a filter in the settings for jobs. We can look at the jobs list both for VM backup and restore operations, as well as Azure Site Recovery, replication, failover, and failback operations. We're, of course, concerned with backup jobs. And sure enough, you see that I'm in the process of restoring the entire hybrid VM. In fact, let me just quickly check on the progress just for grins to see what's going on. Okay, so it's been working on this for quite a while. What we're concerned with is restoring the VHDs from Web2. Let's give this a click. It looks like it hasn't even initiated the subtasks list yet. So once again, it's a case of, as my dad used to say, hurry up and wait. While we're waiting, let us look at Visual Studio Code here. I have a script file for you, an Azure PowerShell script called Restore Disks Create VM. You can find this script file in your exercise files. It's quite a long and involved document. I won't walk through every line, but instead, what we're doing at the high-level view is using PowerShell. Our goal is to restore a VHD from backup, turn it into a managed disk. Of course, from the backup, it's in a restore point, so we have to create a managed disk out of it, and then we can create a new VM using that disk and specifying any other alternate configuration we want. So you'll see that we see some hunk and long command names, get Azure RM Recovery Services Backup Container, and the container type has a few different types. So basically what we're doing is tapping into a Recovery Services vault. And remember, in the GUI, you have your backup items, you have your Azure VM, your SQL, your file share. That's what the container type means. And you can dip into the container and pluck a particular restore point out. That's what we're doing here in the subsequent code. And then on line 17, we're doing a restore Azure RM Recovery Services backup item to pluck that VHD out of the Recovery Services vault. We're checking on its details. We're beginning to build a virtual machine configuration. We're going to create a new Azure RM disk config and a new Azure RM managed disk. We're going to use for each to make sure that we're getting any data disks that may be associated with the new VM we want. And then the rest of the code is just deploying a virtual machine. You have your network interface, optionally your public IP address, your virtual network assignment, and then ultimately you have your new Azure RM VM that ties everything together. Up at the very top of the script file, I have a multi-line comment. This is the docs article in question. I can click this link, actually control-click it directly in Visual Studio Code because I've installed the link for VS Code extension. One thing you should really be on board with, besides being on board with Visual Studio Code, are extensions. They're really a fantastic way to extend the functionality of VS Code. So I'll just pop this open, and this takes you to the Restore an Azure VM with PowerShell section of an overall Azure Docs article called Deep Breath. Use Azure RM Recovery Services.backup commandlets to back up virtual machines. And actually, the article covers restore as well. I think this should have a more concise title, in my humble opinion. Let's come back to the backup jobs list. Let's force a refresh and see what's going on. Looks like we're still in progress for those VHDs. Okay, it looks like our Web2 VHD restore process is completed. So let's take a look at the results here. This was, in fact, a recover disk job type. The target storage account is EastRG-Diag716. That target storage account is important here. In fact, let me switch over to Azure Storage Explorer. I've drilled into that storage account, and in the blob service, we have a container named after that VM, Web2, and then a GUID after it. And here's where we can see that disk that we've brought out of Recovery Services Vault. And we can also see Azure Deploy and Parameters JSON files. Guess what that is? Let's come back to the portal. That is the underlying JSON deployment template that you'll want to use to create a VM based on this restored disk. If you had any OS disks, you'd pull those back as well. But this web VM, this Web 2 VM, has only one OS disk. Let me click Deploy Template here. This opens the custom deployment dialog. We can edit the template or just the parameters here. Let's choose Edit Template. This is where we can get to the environment of the disk. Notice that we also have a JSON definition for the virtual machine as well as its network interface card. If we expand parameters, all that stuff is broken out into the JSON, and we can make edits here however we want to. And if we want to pull down the files and work with them locally, we can certainly do that. In summary, the takeaway points that I want you to walk away from this module having learned are, number one, that the Azure Full VM Restore is a great quick create option. That is, if you're restoring a backed up VM and you don't want to change its instance size or its other configuration, you're happy with the configuration as it exists in the restore point, that's fine. But use the restored disk scenario to gain full control over the VM recovery environment. That's probably the biggest takeaway I have for you. And remember those dependencies. For instance, the restored disk allows you to start from scratch to choose a new availability set, let's say, or associate with an existing availability set, change your virtual network interface card and/or VNIC properties, and of course, there's private and public IP addresses. In the next module, as promised, we're going to look at recovering files and folders from VMs. I'll see you then. Thanks for your attention and participation. Hello there and welcome to Pluralsight. My name is Tim Warner, and this module is entitled Recovering Files and Folders from VMs. If you've been with this course sequentially, and I hope you have, you understand the VM backup and recovery workflow pretty well, from the entire VM and individual VHD perspective. But here we're going to look at a feature called Azure VM File Recovery that enables you to retrieve file system resources directly from your backup disks. It's a very good convenience, and I think you'll like this feature a lot. Let's get right to it. Understand Azure VM File Recovery. The use case for Azure VM File Recovery is something like this. You hear from your manager, we need to retrieve a few log files from 3 months ago. Time is of the essence. In other words, the boss needed them yesterday. Well, if this is from a VM backup and that data disk in question is 40 gigabytes or 140 gigabytes or a terabyte, then downloading that thing to be able to mount it on your administrative workstation may be out of the question. Instantiating a new VM is going to run up costs. What can you do? Well, we have Azure VM File Recovery to help us here. There's 4 steps in the Azure VM File Recovery workflow. First, you select the recovery point that you want to investigate. Second, you download and run the PowerShell script that the Azure portal provides for you. You run that script from an elevated console prompt or whatever your IDE is on your administrative workstation, and the recovery point disks will be mounted as mapped network drives and therefore accessible on your local system. You recover the file system resources using good old drag and drop or programmatic copy, whatever you want to do, and then you finish by unmounting the disks after recovery. Easy peasy, right? Well, it really is. We're going to retrieve file system resources from a VM backup right now. No more need for slides. We're going to do this entirely in a practical demonstration. Let's do this. In this demonstration, we'll work with Azure VM Recovery. What we're looking at right now is the desktop of my Windows 10 administrative workstation. If I come out into the portal, we can take a look at my hybrid VM virtual machine. This is a Windows Server 2016 VM. Let me filter the list for backup. And in the backup settings blade, you can see that I have been running backups on this server, and I have 2 application consistent restore points to concern ourselves with. Let's imagine that we need to retrieve resources that are deleted from the running VM. And as a matter of fact, as luck would have it, I have an RDP connection to that virtual machine right here. And I have shortcuts on my desktop, one that go to my data disk. I have a scripts folder. Whoops, I just deleted those scripts. And I have another in my documents folder, a number of Excel files. They've been accidentally deleted, and wouldn't you know it, the recycle bin has been accidentally emptied. Uh-oh, how can we get those file system resources back on this virtual machine? There's the question, isn't it? Well, this is a good use case for file recovery. As long as you have at least one good restore point, you can go back in time and retrieve assets from the OS and/or data disks. Let's start by clicking File Recovery. Of course, we'll want to select the appropriate recovery point, and I'll want the latest one, which is as of yesterday afternoon. And in step 2, we'll download a PowerShell script that'll mount the disks as local drives on my machine, and as the text says, these drives will remain mounted for 12 hours. So I'll download the executable that will run the PowerShell. It's generating not only the PowerShell script, but will also give us a password that we'll need to copy into our clipboard. When the executable's ready, we'll be prompted to run it in place. Now I'm actually going to do a save as and put it on my desktop. It's got such a long name, I think I'll put it at the root of my drive E, my data drive. The reason why I did that is we're going to need to run that file elevated. So I'm going to first click to copy the password, then I'll right-click Start Come to Run. I'm going to do E: to open the E drive, right-click that file, run as administrator. Because the executable is surprisingly not digitally signed by Microsoft, the Smart Screen filter is protecting us. I'm going to choose More Info and Run Anyway to bypass. We're again given a user account control consent, and we're now in an administrative PowerShell console session. I'm going to see if I can sneak in here and modify the font size to make it easier for us to read. It asks us for the password. I'm going to Control V to paste that in. It's going to rely upon the iSCSI initiator client on my Windows 10 box to make that connection over the internet. All right, so following through, it looks like we have 2 recovery volumes attached. Drive F, which is the virtual machine's data drive, and mapped to my G is the system drive, or the operating system drive. And it tells us we can open Explorer to browse for the files, and then after recovery to remove the disks, use step 3 in the portal. I'm going to press Q to close this window. And as stated, we can now use File Explorer to make a connection to those remote disks from the Recovery Services Vault. Here's that data drive here, drive F, and here's the scripts folder. I'm going to actually right drag and copy that to my Windows 10 workstation. We'll come back, and now let me go to my G drive, which is the virtual machine's operating system drive. And you'll remember I had in my users, Tim, documents folder, we have all of our Excel files. Cool. Well, I'm going to, again, right drag to copy that entire docs folder to my local machine desktop. Let's close out of File Explorer and come back to the Recovery Services Vault. And we can cleanly unmount the disks and close the connection by clicking this button. In the name of sweeping up the shavings, we can bring up that RDP connection to my virtual machine. And in my scripts folder, I can easily repopulate all of those script files that we just restored thanks to Azure File Recovery. Here we are. And then in our documents folder, let's open it up the local machine. I'll do everything but desktop.ini. I'll copy these files and restored. Good job. Done and done. What have we learned in this module? Well, I want to congratulate you because at this point you understand how to use the Azure VM backup and recovery tools in several different contexts. You know how to take backups, you know how to restore entire VMs, you know how to restore individual disks, especially when preparing new VMs based on those snapshots. And in this module, you learned how to use Azure VM File Recovery. We're going to finish the course in the third module by looking at the other side of the disaster recovery coin, business continuity disaster recovery in a failover context. You're going to learn how to use Azure Site Recovery, or ASR, to provide failover recovery and really short recovery time objectives for your Azure VMs. I'll see you then. Thanks for your participation. Hello there and welcome to Pluralsight. My name is Tim Warner. The name of this module is Providing Failover Recovery for VMs. We're going to begin this module by understanding the Azure Site Recovery use cases, and we'll focus in on one in particular, configuring VM replication in an Azure to Azure context. By the end of this module, you'll understand how to configure replication as well as test and perform failover and failback. Very important skills in this lesson. I look forward to teaching you. Let's begin. Understand Azure Site Recovery, also called ASR. ASR is a replication and orchestration engine, okay? Replication, as you probably know, refers to keeping replica copies, that's what replication relationship is, in synchronization with each other. So we have on the left here, it looks like we've got primary and recovery, disaster recovery physical sites. And you've got Hyper-V replication being the channel between those sites. But notice how you can plug the Azure cloud into that. Now, you can use Azure Site Recovery in many different topologies. Some businesses, in fact, many of my consulting customers, use Azure as a recovery site, which means that you don't have to have another physical co-location. That can save you big money. And there's also all of the agility and flexibility that comes with Azure. So on-premises to on-premises is another example where you're using Azure Site Recovery as an orchestration channel. Another neat thing about ASR is that you can replicate, failover, and failback not only Hyper-V virtual machines, but also VMware ones. Now, all of that is great when you're involved in a hybrid cloud environment. But what we're going to do in this module is look at the Azure to Azure, or what Microsoft employees call A to A use case. A little bit more, though, on ASR architecture in general. I mentioned that you can use Azure as a recovery site, and that's absolutely true. Some customers will actually set up Azure Site Recovery and make sure that their on-premises Hyper-V and or VMware workloads are replicated into Azure and in sync, and then they will stop replication and decommission the on-premises copies. In other words, ASR provides an excellent front end for migrating to Azure. And this could be a migration from on-prem into Azure, or it could be migration from another cloud provider, like, for instance, Amazon Web Services. Once again, I want to drill in that we're dealing with both hypervisors. ASR natively supports Hyper-V and VMware. And you know what else ASR supports? Physical machines and virtual machines. You don't need a separate tool to perform P to V or physical to virtual translation to get your physical machines up into Azure. I'm a big fan of ASR, in case you don't already know. Now, ASR can function alongside the System Center products as well. You might have heard of System Center Data Protection Manager. This helps you back up full workloads, full VMs, full workloads on-prem, and shuttle them up to your recovery services vault. Let's learn how to configure VM replication in Azure. Now, I'm going to focus in this module on integrated disaster recovery for Azure VMs. Not too long ago, you had to do all of your ASR configuration from the Recovery Services Vault, and you still can do that. For instance, if you're dealing with entire workloads instead of individual virtual machines, you have to do that. Or, of course, you could use another abstraction layer like Azure PowerShell or Azure CLI v2. But we're going to focus on the disaster recovery setting, which, as you see in the screenshot, is accessible from the virtual machine blade itself. This is a really beautiful thing. Normally, and when I say normally, I mean in my work as a trainer and as a consultant, most of my customers immediately assume that Azure Site Recovery is very invasive and it's a long process and it involves planning. That is absolutely true when we're providing replication and failover failback for individual virtual machines. We can see that this configured disaster recovery is almost a turnkey process. You specify your target region. Now, that's going to need to be a region other than the one where the VM resides. Another neat thing about this is that your recovery services ASR A to A topology is going to provide region-level failover. You then specify the properties of the virtual machine, its environment, its resource group, its availability set, and virtual network. And notice those drop-down controls where you can specify once you've failed over the virtual machine, where will it reside? There's some storage, replication, and extension settings that you can add here. Extension settings is cool because you can use Azure Automation and PowerShell or Python scripts to do fix-up operations after you've failed over the virtual machine. When you're doing larger scale Azure Site Recovery, say for entire fleets of VMs, there you can create recovery plans in the Recovery Services Vault that specify the order in which your VMs get restored and brought online, and you can inject code, fix-up code in between. It's a very robust thing. As a matter of fact, I want you to look up my courses on disaster recovery in the Pluralsight library. I've done one just recently, as a matter of fact, where I think the course is called Migrating Physical Servers to Azure. And I walk through ASR from soup to nuts there, so you'll learn how all of the details work. But even from within the context of the virtual machine blade, this is really great functionality. Once you're finished with your settings, you enable replication, and off you go. Now, the initial replication is going to take a little while, as you would imagine, but once the replicas are in sync with each other, it's just going to be changes that are put over that connection. And this demo will work with replication, VM replication through Azure Site Recovery. And our goal here is to take this DC1 virtual machine we're looking at right now that's located in the south central US region and replicate it such that we can fail over within a very short period of time. We do this from the context of either the VM or the Recovery Services Vault. Let me do a search for Recovery Services. I don't think I have a vault in the VMs region. And I don't think we worked through creating a Recovery Services Vault. Oh, looks like I do have one called Dev Vault, but I'll create another one here, and I'll call it ASR Vault. I mean, it's really quite easy. I'll put it in its own resource group in the South Central US. The Recovery Services Vault itself is simply a container. In terms of Azure Site Recovery, let me quickly show you just where that exists inside the Recovery Services Vault. I'll pick on Dev Vault for this example. We come down under Getting Started, we have Site Recovery. And then the wizard walkthrough depends on whether you're looking to protect on-premises, virtual, and/or physical servers or Azure VMs. And what we have here is first configuring replication, and then for multi-VM workloads, managing recovery plans where you can orchestrate the order in which VMs start during failover, and you can optionally run scripts through the Azure Automation Service to perform fix-up operations and to make the failover as smooth as possible. Let's come back to our virtual machines blade. I'll filter the list for DC. I'll select DC1 in the list. And in the settings list, we'll come down under Operations, Disaster Recovery. What we have here is a really nice front end to Azure Site Recovery, but here it's in the context of the virtual machine. Remember that if you have need to fail over an orchestrated workload, that is multiple VMs, you'll want to do that from the context of the Recovery Services Vault. Now, normally what I recommend is to choose the paired region of your current region. I'm in South Central US, and I happen to know that North Central US is the paired region, but my subscription won't allow me to do that, so I'm going to choose the next best thing. By the way, Azure paired regions are Azure regions that have very high-speed connectivity between them. They're used for geo-replication because of the fact that they've got that high-speed connectivity. So I like to use paired regions with site recovery in order to make replication jobs go faster. In the first part here, we're determining our subscription and then resource group, optionally availability set, and virtual network. What I want you to see here is that Azure Site Recovery will need to place the replicated and failed over VM into an environment. And that's what you're specifying using these drop-down controls. Below that, we have details for storage settings. You're going to need a storage account to serve as a cache, because after all, we have an ongoing replication of deltas, changes, from the source VM's OS and data disks to the failover region. By the way, what we're setting up is what Microsoft calls A-to-A ASR, or Azure to Azure, Azure Site Recovery. For replication settings, this is where we can specify which Recovery Services Vault we want to use. And we can also specify which replication policy we want to use. You'll get additional options there if you've created additional policies in the Vault. And then for extension settings, you can specify that ASR manages updates, or you do that yourself. And then if you want to use Azure Automation, you can specify an account. Finally, down at the bottom, you see a really nice graphic that shows you your source region, your selected target region, and others that are available for doing this. When you're ready to start the process, you click Enable Replication and off you go. Now that initial replication job is going to take a long time, as you can imagine. You can check the status of it in the Site Recovery Vault or directly within the Disaster Recovery setting. Let's go back to the Virtual Machines blade. I have Azure Site Recovery Replication already set up for my VM West VM. So let's take a look at it. We'll filter the settings list for disaster recovery. Here we go. And we can see if we scroll down here that our replication health is healthy, the status is protected, and Microsoft says that we have a recovery point objective of 32 seconds. That's pretty good. Also, we see a list of the latest recovery points. App consistent is the best one. Crash consistent is the least preferable, but it's certainly better than nothing. In the next demo, we'll actually work through failover and fallback. Perform failover and fallback. Microsoft strongly recommends that you perform at least one disaster recovery drill by doing a test failover. Now, this is not only for individual VM recovery like we're doing in this module, but even larger scale environments. Why? Well, you always want to practice. If you've ever heard of the carpenter's aphorism, measure twice, cut once, that makes sense. And also, honestly, when you're in an honest-to-goodness emergency, it's nice to have the experience and the muscle memory of actually going through this so you know how it works. Test failover, you need to do it operates in stages. Azure will perform a prerequisite check to make sure that it has everything it needs with regard to Azure resources. The failover will actually happen. Now, you're not going to cut service over to the restored VM. You're still using your primary VM, but Azure Site Recovery will, in fact, create a recovery point and restore the virtual machine to your recovery VNet and start the VM so that you can establish connectivity and verify that your fix-up scripts are working and so on and so forth. You need to remember that what ASR does during the replication, it's not like your VMs are actually already deployed in the Recovery Services Vault. It's just the OS and data disks that are being kept in synchronization. So when you flip the proverbial switch to do a failover, Azure's got its work cut out for it in deploying a VM using those disks and configuration as quickly as possible. After your test is complete, you can just literally click a button in the Azure portal and Azure will clean up all of those resources for you and remove them. That's good because you don't want an extra VM or VMs running when they don't need to be. In this demonstration, we'll work through failover and fallback with Azure Site Recovery VM replication. If you've been following this module sequentially, in the previous demo, we configured replication for a virtual machine. I showed you how that works from the context of the VM. We're looking at my West VM virtual machine now, looking at the disaster recovery setting. And because this machine is protected and it's up to date, we can perform either a real failover or a test failover of this box. Let me click Test. I've already performed a test failure on this machine to verify that it works. But the way that the workflow works, if that makes sense, is that you choose your appropriate recovery point. It'll default to the latest one that gives you the lowest recovery time objective. And then you specify which virtual network you want to fail over to. I have a couple ASR created ones that I could choose. You get a warning that says it's recommended that you test failover to a different VNet from your production one. In fact, that's important here because it looks like this VM is already on West RG, so that's not going to work. So let me choose Pluralsight VNet ASR. And if I click OK, Azure will in fact do a failover. Your existing VM will stay just where it is, but Azure will build a new virtual machine in the recovery environment based on the latest and greatest, based on your recovery point that you've selected, operating system and data disks. What's neat about that is that once the failover completes, you can then verify that it's worked, that you're able to get to that virtual machine in the recovery environment. And then with one click here, clean up test failover, Azure will delete all of the assets that it created during that failover process, which is pretty convenient. The workflow for failover and failback works like this. We first initiate an honest-to-goodness failover. Once we've failed over, we can still optionally apply a different recovery point if we need to. But once you know you're where you want to be with your chosen recovery point, we click commit, and that finalizes the failover. And at this point, you should be pointing your services to the recovery environment VM and not the source one. Check the exercise files for some additional guidance on configuring Domain Name System, or DNS, for failover. What you'll do to fail back is 2 steps. One, on the failover VM, you'll re-protect it, which then finally gives you the ability to perform another failover, this time back to the source environment. Key to understanding that is that there's not a fail back button as such. You're simply failing over in the reverse direction. So let's go through this. We'll click failover. I'm going to choose my latest processed recovery point, and the default option, and this is a good one, is to force the source virtual machine to shut down before beginning failover. I hope you can see why that makes sense. We don't want to confuse our applications and users and have 2 identical, or basically identical, VMs up at the same time. We can open the notification bell and click the starting failover job to be taken here to the site recovery job list, and we'll want to pay attention to the job tasks. We see that the prerequisites check has completed successfully, and Azure is now forcing the source virtual machine West VM to shut down, after which it's going to synchronize the latest changes from the source VM into the recovery point, start the failover, and then finally start the replica virtual machine. As we can see from the duration list, in about 5 minutes, we've got our failover complete. Now let's click Environment Details to get a handle on what's going on here. West VM is now running in WestRG VNet ASR. So let's come back to Virtual Machines. Filter for West. Now you'll notice that the public IP address that was associated with the source VM has not been migrated over to the failed over instance, but you will notice that the private IP address still matches. Let's select that failed over virtual machine, come down to disaster recovery, and as I mentioned, we can either commit the failover to the current recovery point, or we can click Change Recovery Point to specify a new one if we feel that we're in a better ground choosing a different recovery. But I'm not. I'm going to commit this. We're warned that once we commit, we cannot change the recovery point of the virtual machine. That's fine. Let's open the notification bell and verify that we've completed that failover commit. When we're ready to fail back to the source environment, as I mentioned before, we'll want to re-protect this VM instance. Now we can customize the resource group, the virtual network, the storage, the availability set. But as the text tells us here, by default, Azure Site Recovery will go back to the original location. And that's exactly what I want here. So I'm going to click OK to enable reprotection. Again, we can follow progress by opening the notifications bell. Cool. Once reprotecting the virtual machine finishes, we need to wait for synchronization to take place. And again, this is going to take a while. Let me scroll down a little bit. Notice how the replication health is healthy, but we're 0% synchronized. The idea now is before we can trigger our fail back, we have to make sure that the source virtual machine OS and data disks are in sync with what we have here in our recovery environment. So I'm going to need to stop the demo now, but you've already seen how a failover works, and that's exactly how failback works. Once synchronization reaches 100%, we'll be able to trigger that failover and come back to our source environment. I hope that you learned a lot. As far as takeaways are concerned, I think you'd agree with me that Microsoft has done a lot of great work making Azure Site Recovery as easy to use as possible. We are doing a relatively simple use case here. If you want to do ASR for a larger workload, especially in a hybrid cloud environment, the topology and infrastructure does get more complex, but nonetheless, it's still so much easier to use than what are the alternatives? Manual work? I don't think so. VMs in Azure have an almost turnkey business continuity and disaster recovery solution built right in. It's right there. It's available to you. It's a wonderful thing. So anyway, I want to thank you for hanging with me. Again, I hope you learned a lot. If you want to reach out to me and connect for any reason, please feel free to do so. You can find me on Twitter at TechTrainerTim. I suggest you follow my account, not only because you can send direct messages, but also because I post Azure News and Pluralsight course updates every day. You can also reach me via my work email address. It's timothy-warner@pluralsight.com. Thanks again, and I wish you all the best. Take good care.